Hello, welcome to Verkle Implementers Call 19. This is issue 1064 in the PM repo. Okay, starting off with client team updates. Who would like to start things off?
I can do Ethereum JS. So we are working on a Verkle try implementation while waiting for the next testnet to test on. We should be ready for Costinent 7 in terms of gas cost updates and like the basic leaf data and the way these things are going to be now architected.
So I can continue with Bezu, so the Java client. On our side, I think in terms of the gas costs, it was decided to wait for a little bit more stable spec. I don't know how, so I missed a couple of the last implementers call, so I'm sorry if I missed some things, but I think the team decided to wait for a test framework for the gas cost. We meanwhile are thinking about the migration, the sync, and how, in particular, we can retain the flat DB while doing the migration. So there's an issue that we have that since we are storing with Verkle try the flat, like sort of the flat DB is by stem. It's like we store the values by stem and we index them by stem. That comes from a hash from some sort of a hash from the account and storage key. But before we had get track of the address and get track of the code or something like this. We cannot retrieve that information from the stem, so we are wondering if we'll be doing like sort of two reads to make sure that we trying to read in the Verkle, or if it's not there, then trying to read in the old FlatDB during the migration. We're trying to avoid that, and we are not exactly sure how to proceed at this point. But that's so that's one of the questions. And I don't know if Gary is there. You could comment more on the gas costs. But we also have, meanwhile, also another thing is we're trying to optimize the storage between FlatDB and the nodes, what we're going to store. So that's where we are now.
Okay. Yeah, we've been working on the test framework and adding tests. So both I and Ignacio have worked on different aspects of it with the testing team, of course. And otherwise, yeah, we've been collecting data to study a series of answer some questions that have been asked over the years, or over the last few months, actually. For example, the extra gas consumption with or without EOF, or the size of the witnesses, things like this. Also, the size of the time it's going to take to make the transition. We don't have, so we collected the data. We don't have a complete analysis yet. It will be published, in hopefully the next 2 weeks, or before the end of the summer for sure. And we were also working at the spec update changes. I think, I mean, we kind of had an agreement. So addressing what Thomas has said, the spec is pretty much set in stone. It just needs to be updated. So this is what I'm doing. I mean, it's never set in stone until, of course, it's been released. But we have a pretty clear we have a pretty clear vision of what we want to achieve now. Yeah, I don't know, Ignacio, you've got something else to add?
No, just to expand a bit on my side on that is for 4762, 6800, and the other one that I don't remember the number. EIPs. I already finished the test vectors. Everything is a bit on the air because there are some library changes that we need to do for them to be filled. But I already assumed the 4762 gas changes that we have been discussing. So probably after the testing library pending changes are done and all that, I can probably fill all these tests, and as soon as I have the fixtures generated, I can share that with all our clients for them to run. And regarding this other analysis stuff, I've been collecting around 1 million mainnet transactions on the tip of the chain the last few days using the Geth Live Tracer. And my idea is to basically collect all the program counters that all the transactions touch when running, and using this to simulate how much gas the 31 byte chunker and 32 byte chunker will use. First, to compare both options, because we have like some theoretical understanding on pros and cons of them. But I mean, the only real way to really know is by like kind of simulating them on real transactions. And apart from that comparison, just knowing how much of gas overhead will cold accessing add to transactions, which is pretty important to know from data, from real data. So yeah, probably in the next big call, I will have some report with all this, and I can share the results, and we can go on from there.
Cool. Any other updates?
Yeah. So no major updates from Nethermind. They're still working on improving the cryptography performance and like getting the sync to work. I'll probably have some more updates in the next week. I just had one comment. I think the transaction fuzzer is not working on the Costin 6 testnet. So if you can fix that, will be better to test the sync.
Cool. Anything else? Any other updates? Anything on the testing side?
Hey guys, yeah. So I believe last time we spoke, we had the transition tests working, filling and executing on Geth with some failures, but that ended up being somewhat incorrect. So we had some false positives of, I guess, the test that we filled, and this was on our side. But now we've resolved the bugs for that for the most part, and we're now filling and executing the transition tests on Geth with very small number of failures. So there are I believe 12 failures right now, all specific to withdrawals, and I'm fairly confident it's a small bug on our side that I just need to still need to fix. But at the moment we have all of these transition tests passing on Geth, and we hope to make a release of these transition tests for every client to utilize. And during this process, there was some back and forth with Guillaume regarding the transition tests, and I guess it led to some sort of overkill way of how we can really throttle, like overly test the transition, especially on the transition block. I can maybe share something real quick if that's okay.
Yeah, sounds good. Are you able to share? Give me 1 sec.
You guys see my screen okay?
Yes, I can.
Yep. Yeah, so I guess with regards to transition tests, I guess the 3 types of tests that I guess the conclusion we came to is pre-fork transition tests, the mid-fork transition tests, and the post-fork. So with the pre-fork, ideally we want to. So I guess before I get into this, these are tests that we already have, tests that test many things on all the forks previously. So these are filling tests that we already have that we want to utilize for testing Verkle. So yeah, so the pre-fork transition tests. What we want to do with these is we want to execute all the test blocks before the Verkle transition block, so that the MPT is filled, and then afterwards we add some dummy blocks after the Verkle transition block, so that we can verify that everything's executed properly. And we also have these mid-fork transition tests. So this is where we execute the test blocks on the Verkle transition block. So the basic approach is just for existing tests. The first test block for an existing test, that block could be executed on the Verkle transition block. But ideally, we want to update our framework so we can, for example, let's say we have a test with 4 blocks. We want to execute each of those 4 blocks on the transition block. So for one test with 4 blocks, that would essentially output 4 specific to the test block executing on the fork transition block. And then we also have these kind of post-fork transition tests where ideally we start with some dummy initial MPT, and we perform the Verkle transition, and then once the transition starts and there's some stride enabled, we'll then execute these test blocks. And we can get kind of somewhat crazy with this, at least with the way we fill the tests. So I guess the most basic form would be with 0 stride, which is what we're doing right now. And for the pre-fork transition tests and the mid-fork transition tests, with no initial additional MPT. But ideally, once we have these tests ready and clients are passing them, we will then, I guess, add some initial MPT. So we have a really large MPT, and then also stride as well. So, and we can kind of fill these tests accordingly. And my hope, so this is specific to our framework, but my hope is that we can fill the tests with these kind of fields true. So if we want to fill tests for pre-fork transition, mid-fork transition, post-fork transition, the amount of MPT accounts, additional MPT accounts that we want to add and also enabling stride. So ideally, we can just write the fill command with these parameters and very easily generate the test that we want regarding the transition specifically. And yeah, my hope as well is that we can kind of make simple releases first and then build on top of them and make them more complex. But yeah, currently the tests we're focusing on for the transition tests are these mid-fork transition tests. The basic approach, where just the first test block that we have is executed on the Verkle transition block. And yeah, that's kind of it with regards to the transition tests. It's something which I personally overlooked when we were generating the test before, but it's a step in the right direction. And yeah, so just to summarize that, once we finish with the basic transition tests, we'll create this release, and then we'll focus our attention on all the test vectors that Ignacio has been writing for the Verkle specific EIPs. So then we can fill the genesis tests. So starting at Verkle. If anyone has any questions regarding this, please speak up if you think this is a good approach, or if we can approach this better.
I just have one question, if I may. So you're using Shanghai for the pre-transition, so it most likely will be Denkun for pre-transition. And even if we do pass this one, should you have to rewrite those tests for Denkun? Or maybe we could just focus on, because we're writing the tests anyways, might focus on Denkun to Verkle transition directly, because I think it's not going to be much time after maybe 3 or 4 months that we sort of hack, continue doing this hacky way. I mean, nothing against it, but just something to think about.
No, for sure. That's a great question. So I guess the good thing about our framework is that it's written in such a way where you can fill from any fork. So it will, on our side, literally be changing the fork name, and it should just work straight away with filling the test from Denkun. So hopefully no worries.
Cool. Awesome. Thanks for sharing this. Any other questions or comments on this stuff? Cool. Up next on the agenda, code size in Verkle and whether it might make sense to raise that to something as high as 2 gigabytes. Dano?
So, based on the comments in the threads, I'm not sure what the current state is, but the basic concern I have, right now, code sizes are limited to 24 kilobytes. And there's a lot of pressure from the Solidity community to raise that number. One of the issues why we don't raise it now, at least prior to Shanghai, was concerns about jump test analysis and having to do that jump test analysis every time we load the code from memory. Because of the way Verkle, well, 2 things happen. Number one, we charge for init code now when you deploy a contract. So if you're doing the jump test analysis, when you're deploying the contract, we charge you gas for that. So the size of the analysis really shouldn't impact the system because it scales linearly with the gas cost. So creation so the analysis at create time shouldn't be a problem. However, what Verkle adds as an interesting twist is they kind of store and cache some of this analysis in with the code. Whether they're going to do the overhang method, which is the current plan of record, or whether we go with Epsilon's only store the places it matters method, that analysis is cached. So when you load it from the Verkle tree, you don't have to do the analysis. And in fact, because you're loading it chunked, you can't do the analysis except for the stuff that you do it with. So based on that, it would be reasonable to increase or uncap it. There are contracts that there's a diamond pattern where contracts are currently using to deal with this limitation by switching between the various contracts and some of those are easily larger than 64K. I don't know if they're going to get up, much larger than, they're probably not going to get 2 gigs in the next 5 years. But the short answer is that using 2 bytes to store the code size, I think, is something that's going to become problematic in the near future, not the far future, as in within months of the Verkle fork. The next fork, we might want to increase it, and we don't want to be up against a limit when we decide to increase it. So my pitch is that whatever we do for the code size in storage it's more than 2 bytes. 3 bytes would be better. That would give us 16 megabytes. I don't think in 3 to 5 years there might be reasonable contracts that aren't explicitly trying to exploit the memory size that would target that. But as far as design processes, casting 4 bytes to a native data size in a programming language is a whole lot easier than casting 3 bytes to a native data size. It's a lot quicker. So if we were going to increase the size, 4 would be the next logical byte length to do it with. But generally speaking, 2 is too short for the Solidity community.
Yeah, sorry, I wanted to raise my hand, but I couldn't find the thing. Oh, it's right here. Okay. I have a couple questions. So, yeah, 16 megabyte. That was actually going to be a suggestion I was going to make, 16 megabytes. Because, right, this is what I've wrote in the issue. Currently, I don't see, 4 gigabytes worth of code being ever practical, right? Or unless you have a different insight into this. No one will ever deploy even 2 gigabytes, right?
640K has got to be enough for anyone for a PC. It's hard to predict the future beyond 5 years, but I don't see it happening within 5 years.
Okay. Right. So what I was going to suggest is to so currently, indeed, in the spec, this is I remember having the conversation that you mentioned during the in the issue. I remember having this conversation, and yes, we were discussing 64 as a limit, saying it would be. I don't even exactly remember what the full context was, but I remember what we sort of agreed on, which was 64 right now, and then in the future we could expand. Okay, so now you seem to think, or you think that that we are going to need a higher value pretty quickly, which is reasonable. My
Within
only
5 years, yes.
within 5 years. Okay, fair enough. Which I mean, depending on how long Petra takes, might be okay. I'm not gonna say Verkle happens in 5 years, but looking at it, Verkle is not happening before end of 2025 at best, in the really very best of cases. So 5 years is like tomorrow. So that's a good reason to expand. What I was saying, like my semi counter was, I don't want to allocate bytes that are going to be sitting there unused when they could be used for something else. Like there's other people suggesting. So if we make the code size 2 bytes, right, that leaves us five reserved bytes in that basic data field, right? There's a lot of people eyeing those 5 bytes. At least there's a few use cases, maybe not a lot, but a few. There's resurrection counters for state expiry, for example. There's definitely state. There's definitely code size. There could be other extensions, like if we want to do account abstraction things, like holding, for example, a bit for whether or not the contract has storage. Yeah, there's a lot of people contending for this, but 3 bytes, I would be quite happy with that. My question is, what did you say? 3 bytes, like 4 bytes is better than 3, because you could just apply a mask and that's pretty easy to do, right? Unless I'm missing something.
It is easy to do. It's more bytes, it's more hassle, it's more ways to make mistakes. In the absence of resource constraints, that would be preferred. But if resource constraints are legitimately strong, then 3 bytes would be better than 2.
So what I would suggest is that we reserve 3 bytes, but we kind of so we put like the way we organize those 32 bytes for the basic data is that we put the zeros in such a way that if we ever need to expand 3 bytes into 4, it will have priority basically. So I would say we put the version number, then those 4 reserved values, then those 3 bytes, then whatever is left in the basic data account. So this way, the code size can spill over into the reserve size if need be fairly easily. What would you think of that? So what I mean is
that would be fine. We would
Yeah.
need tests, however, to
Mhm.
put to fill in those reserved bytes with values and make sure that things still parse. So we could, if we reserve those, we need a test that those don't interfere, especially with the design spillover. That is one test in particular. We want to make sure that people don't just take those 4 bytes and rely on that reserved byte being 0. So we would need testing to cover that case.
Right. Yeah, fair enough. I can add, yeah, Ignacio.
Just was going to say that 3 bytes sounds good to me. And regarding like where to place them, I think it's not really that relevant, because if we want to expand this, we have to set up a new version. So the whole interpretation is different. So this is not like placing them in another place kind of facilitates anything, because if we want to use those bytes, we have to change the version, and that's a completely different interpretation of the slots.
So like if it was like a minor version where it's a forward compatible change where those have no meaning and the 1.0 and the 1.1 have meaning, I think clients could handle that. But if you're changing the order of things, then yes, you absolutely need a new version.
Yeah, that's what I was going to add. Indeed, you don't really need a new version. You just need a new fork to say, well, this byte used to be to always be 0, but now we remove the 16 megabyte limit. So beware that that 4th byte can no longer be 0 all the time. And this way, you would not have to create a new version. That was because honestly, I would rather reserve those 4 bytes right off the bat instead of forcing a new version just for a code size, like a change in the size of the code size.
But my anticipation is that a transition from needing less than 16 megabytes to more than 16 megabytes is going to be at least 5 years off, and is probably going to involve a new version would be beneficial anyway. So it's not the worst case scenario if spilling over requires a new version.
Okay. Okay, fair enough. I'm still going to modify, because I'm currently editing that EIP. I'm still going to edit it the way I yeah, but at the same time, I'm just thinking those reserve bytes would probably be correspond to a new version anyway, so might as well. Maybe I'm just being overly cautious here.
It preserves design space. We don't have to use it.
Yeah. Yeah, okay, let's do that then. I'm going to say 3 bytes, put them really at the big, right after the reserve space, so that we have indeed an open design space in the future. And I will share the updated EIP so that everybody can give feedback and disagree.
Thank you. Appreciate it. It solves a lot of problems now that we won't have in the future because we have more options for space.
Sweet. Cool. If nothing else on that topic, we can move on. Next up, we had any discussion on the testnet relaunch. Just because we don't have a lot of time left on this call, maybe we can try to keep this relatively short. I don't know, Guillaume, did you have any specific things you wanted to ask with this testnet relaunch?
Yeah, I mean, this is a question I want to keep asking until we seriously look at restarting the testnet. So the goal is still to restart the testnet around midsummer, by which I mean like end of July, right? This new testnet would have a few of the bug fixes that were seen on the current Chaos.net testnet. Just add the new gas model, the one we agreed on at the interop and in the meeting last week, and also finally implement the fill costs. Yeah, the question is very simple. Does anybody else want any other feature for this? Otherwise, I mean, I will keep asking at every VIC in case people change their minds. We still have about a month to the launch, so teams should be working on the new testnet, which I think every team does except us. But yeah, basically the question is any other wish list for this testnet.
Are we going to have the pre-state root included in the execution witness? Sorry, I might have missed some of the updates that are going to come in the next testnet.
You're right. The answer is yes, but I forgot to write that down. So yes, we would put the new test root in this new version.
All right, cool. Thanks.
Sounds like no other wish list items for now. Cool. Then we can move to the last agenda item. We have a discussion around pre-image distribution. We had some of this discussion at the interop. There's been some more recent, I guess, discussion and ideas tossed around. So just wanted to, I think a few people wanted to open that back up. Anyone that wants to start things off? I know, Gabrielle, I think you had some thoughts you might want to start with there.
Yeah, sure. So pre-image distribution, we discussed that at the interop. One of the ideas that came is, well, during the transition period, well, as we all know, the issue is that, well, some of the state is accessed from the frozen MPT, and without, we're not able to convert to the Verkle try unless we have the pre-images. Now, to most of the, if someone does not have the pre-images, they would be not able to sync the network, right? Because they wouldn't be able to access the state that is necessary to execute the blocks. Now we have some space during the transition period because the execution witness is not actually useful until the full transition to Verkle. So what came to mind is, why not use this space to provide the actual pre-images that have been converted? So a block could contain all the lists of the addresses with corresponding like storage slots when storage has been accessed, leading to the leaves that have to be converted in order to perform the conversion from the MPT to the Verkle try within that block. So we could have a field inside of the execution witness called converted pre-images, and then someone who's validating the chain would be able to access their own local frozen MPT, know which leaves to convert from these pre-images, convert them to the Verkle try, and also execute the block. The main issue is with that, in addition to the space that it uses, which in my view is not really a concern, because we can definitely like do without, in my view, like the execution witness anyways during that transition period. And the size that we're talking about is not that large. The main issue is that you're still not able to produce blocks. You're only able to validate blocks, because we still require someone to have the pre-images locally accessible in order to build a block and provide these pre-images in the first place. It reduces the scope of the problem, because you can always delegate block building. You can always, if you want to have the burden of building blocks yourself, download them through your own means, but at least someone who didn't go through that process is still able to perform all of its duty as a validator except the block building part. So I think it doesn't fully solve the how are we going to distribute the pre-images, but at least we have a very interesting plan B for users who don't want to go through the burden of storing that themselves. Yeah, Guillaume?
Yeah, I was just thinking, is it true though that we can, like those validators that do not have the pre-images can delegate to the builders? I'm not so sure, because in the current model, what we want to do is start the sweep of the iterator in the previous 12 minutes. Sorry, in the previous the last 4 seconds of the previous slot.
Mm-hmm.
And that means that if they don't do this at this time, they will have to do it when executing the block that they are being given. And so there's this the first 4 seconds of the block when they would have to do this. So I'm not sure you can actually pull this one off.
How interesting.
Unless
You could provide the future pre-images to convert.
yeah, unless exactly the pre-images you pass are actually the pre-images for the next block. Like yeah, that could work. I don't know if it works, but I mean, it would solve this specific problem.
Yeah, well, if it depends, like, yeah, I hadn't thought about, the kind of processing when we want that processing to happen. If we expect people to begin converting the pre-images because before they hear of that block, then we need to kind of front run it by block. Yeah, that makes sense. Yeah, Tanishk.
Even if we add pre-images, like first, like getting the pre-images for the next block will be a problem. Like will not be able to add the pre-images that we'll need to process the next block in the current block. Because again, it's the same problem that we do the pre-image processing in the next 4 seconds. So like it will end up taking much more time for the block builder to like kind of process 2 set of like sweeping operations to generate pre-images for the next block. And another problem with this is the first transition block will also be a problem.
Well, you can always make at least the first transition block. You can always make this sweep start just before, like the block before. So you would initialize it this way. Yeah, no,
You can also start the sweep one block after, and the first block is just you just indicate which ones to sweep in the next, and then begin sweeping. But this whole, like, if we had, for example, an exhaustive list of all the leaves that have to be converted, like with the pre-images, that's frozen at the transition time, right? So let's say we just decide based on ordering that we're going to convert 10K leaves per block. This is deterministic from the transition time, right? So someone could, in theory, just have all of that like ready way before. And of course, you have to actually update the Verkle try at the right time so that the state matches. But I don't see why it wouldn't work to just announce it one block before so that people have that time to begin the processing.
Yeah, I think then we'll have to like go back to the model of pre-images where like everything is sorted in sequence, and that again that the problem with that was that the size becomes quite big because there are a lot of repeated pre-images. But I think if like it's kind of a trade-off. Like if we want to do this, then we'll have to go back to that image model where everything is sorted in a way that it will be swept. Yeah, I think we can do that.
Yeah, there's been in pre-image distribution discussions, there's been mentions of like if we want to exhaustively distribute the pre-images to all clients and have a in protocol way of like signaling that, that's also that can also be challenging for clients or nodes to be able to announce that. That also requires some additional thought and coding. If we at least have that, and I still see this as just a backup plan. I'm not really happy with people like delegating block building. I'd rather have everyone have the pre-images. I'm just saying that it seems like such a like engineering challenge to get like everyone on board that I'd rather have a like somewhat satisfactory backup plan to validate blocks and then have a smaller scoped distribution problem. So yeah, we kind of can do away with like just allowing a lot of time for people to download it, but not having requiring people to signal it in protocol and then begin the transition at that point. which is something that was mentioned as a proposal. Yes on that?
So I think the pre-images should be there in the previous block. Associated to that is the question, how would you know what pre-images are to be considered for the next block? Now, at the point of frozen Merkle 3, there would have to be some sort of an index that, from n to n plus 10k, you're going to convert to Verkle. But say there is a bug, I 10,000 leaves have a few discrepancies with another node's 10,000 leaves, which might or might not be acting maliciously. By putting it onto the block, we might have another angle of debugging as well. So
Yeah.
I'm not saying like do away with redistribution, but I'm saying have both of them.
Yeah. I think even if, so I'm still assuming that clients would, like, there's no stateless execution at that point, right? So everyone has the local state, including the frozen MPT. And I don't recall exactly what the conversion like spec is, but my understanding is it's defined based on like the key of the leaves. So even if Block Builder proposes like 10K pre-images, you're still able to validate that these pre-images correspond to the actual leaf keys that you have locally. Let's say you've sorted them somehow that you know that the next 10K are the ones that have to be converted. And if there's one missing, or there's one extra, or like there's a gap where it starts at the wrong place, the wrong index, then you're able to like refuse that block. So you're still able to perform all of your conversion duties except providing the actual pre-images to be converted.
Yes, but there has to be a confirmation in protocol that the frozen MPT is exactly the same for everybody. Of course, there is the root. I'm not so sure if the indexing. So I don't know. So we're just assuming that everybody's going to use the same index at that point. So it's a fair assumption, yeah.
Yeah. Well, maybe Guillaume, you can describe. I'm not sure myself. Like, how were we planning on having consensus on which leaves have to be converted to which block?
Right. So the way it happens is simply a lexicographic enumeration of the tree, right? So everybody, I mean, maybe not has the exact same index in terms of database indexes, but everybody has the same view of the tree, right? Because it's the last block, the last MPT block. So everybody has the same content. So everybody can iterate, and everybody should see the same iteration of accounts. And then for each account, if there's state, you also iterate it you iterate the leaves of the storage in lexicographic hash order.
Mm-hmm.
So what this means is that, yes, you can verify, like if you're given a block with the pre-images for the next block, it's relatively easy. It's a bit IO intensive, but it's relatively easy to check that every single one of those pre-images correspond to your next 10,000 leaves. And if those 10,000 leaves don't match the pre-images that you are being given in the specific order that you have been given it, then you should reject the previous block, because that means there's a disagreement on the state of the frozen MPT, and in that case, you are on a different fork that happened that happened before the tree was frozen, basically. Perry said something.
Yeah, I can also just read it out. How would this work if the last MPT block comes in really late, or if it's reorged out? Would you then just restart the transition with that being taken into account, thereby just delaying the first transition block? Or, okay, to use that is already finalized. Okay, cool.
I think we want to go with the finalized. Oh, I just saw the message from Ignacio. Yeah, he said the same.
Yeah, thanks.
Right, and I thought you were actually asking something else. If a reorg happens during the conversion process, so the MPT is finalized, but you might have to replay the iteration of the tree itself. This is what you have to do in case of a reorg anyway. So it's not connected to the pre-images. I mean, that's not the question you asked. It's just a precision I'm giving for better understanding.
Yeah, I'd be curious to hear, do people generally feel like this would be a valuable thing, or?
I, for one, think it's a good idea, but it doesn't solve the core problem. But it, like you said, it makes it more easy. It makes it easier to handle. So I'm generally favorable to it. It's just my opinion, of course, and I might change it after I implement things. But yeah, I think the core of the problem is still there, unfortunately. But it's a nice trick, and it definitely is helpful.
Yeah, okay, that's my feeling also.
Do we have a sense of implementation or complexity yet of doing this? My assumption was not a lot.
I don't think it's very much.
Yeah, gotcha.
I mean, that's
yeah.
me again when I implemented it, but yes.
Yeah.
Yeah.
Gottfried has raised his hand.
Yeah.
Yeah, just a quick question. We are assuming here that for a missed slot, we do not do any sweeping, right? Because otherwise, due to this delay of one block, this doesn't work. Just to be clear, that this doesn't allow us to do more sweeping or whatever for transition if some slots were missed.
Yeah, we would not be doing any sweeping, and probably no sleeping either during this transition period. But yes, I think with this approach, it would be even worse to actually have to process, because if you have a reorg, that means your block that has all the pre-images would become really large.
Yes.
But isn't that also a benefit of providing the exact pre-images to be converted or that have been converted in the block itself, right? Is you can actually, yeah, I'm wondering, like, that brings me to the thought, like, since we've sort of just said that it would be helpful to have the pre-images not that have been converted in this block, but the pre-images to convert in the next block, then what happens if that next block is, empty? I mean, you might have begun the conversion process yourself, but then you notice that this is an empty block, and then you have to roll that back, right?
You mean empty, like a missing slot, or
Yeah,
a block with
just a slot, like no block has been proposed.
Then the sweep happens in the block after that, the first non-miss slot after that. So it's going to be useful anyway. Yeah.
Yeah, I guess that works. Yeah, that's right.
Cool. Well, I'm sure this won't be the last discussion on this question of pre-image distribution, and maybe we can come back to it in the next Vic or continue the discussion asynchronously.
Which EIP is the conversion process, and like if I want to add this as a addition to an EIP, where should I add that? Is that 6800?
No. There's another. So the conversion has been described in 2 EIPs, but one of them hasn't been created yet. It's I'm still looking for the right wording for it. So the first one is 607612, which just describes the overlay method, but doesn't describe the conversion. And the
Okay.
reason why it's split in two is simply because I expect people to say, "Oh, the conversion is a bit too much for this fork, so let's just go with the two trees, and then do the conversion at a later time." It's basically to offer some flexibility. So far, people think they should come together, and I agree. But I'm expecting, yeah, I see it as some failure mode, basically. So there's
Right.
another EAP that should come, but I haven't had the time to do it yet, to complete it yet. I can try to finish it in the next 2 weeks and ping you then, and then you can add your stuff to it.
Cool. Yeah, perfect.
We don't have that much time left, but did Perry also want to present something, or did they dream that?
Perry is here, but I don't think. Oh, Perry
Yeah,
vanished.
I don't think there's much to say, but I can just bring it up as a general topic. There is like increased discussion around EIP 4.4s and a thought around whatever methodology we use to distribute the historic state, the history in 4.4s could potentially be reused in Verkle as well. But yeah, that of course has the downside that 4.4s is not defined yet, and it's not smart to layer research topics on top of each other. But yeah, just a thought I wanted to put out there.
Right. Oh, sorry. Yeah, my question was, you also wanted to prototype this for 4.4s. Has work started on this?
Yeah, so there's one proposal I made last week on ETH Research that's using torrents for 4.4s. The main advantage of torrents being that they're an extremely mature piece of technology that has existed for 20-something years at this point. And it gives us a lot of the feature sets that we already want for 4.4s. Initial reactions from client teams seem quite good. I think they're at least going to be playing around with it to see if it's feasible. I can link, Josh just linked the post. But yeah, theoretically, you could reuse the same methodology for pre-image distribution as well.
Cool. Anything else in the final minutes?
Yeah, maybe just add some information about this. I have been working on the conversion a bit in the last 2 weeks, or actually the last month. It takes about a day and a half to produce at least that's what it takes Geth. I'm actually not quite sure how long it takes Aragon, for example, to produce this, but Geth would take about a day and a half to produce such a file.
Aragon takes 2 hours.
That's nice.
Cool. All right. Well, I guess we can leave things there for this week, if nothing else. Thanks all for joining. See you guys next time.
Yep. Thank you.
Thank you. Bye.
Bye.
See you.
Bye-bye.